I'm Deborah and I'm a physicist.
And I'm Becky and I'm also a physicist. And today we're here because we volunteer for the Institute of Physics. Because we're both physicists, we're members of the Institute of Physics. And the Institute of Physics is an organisation that supports physicists and helps lots of people enjoy physics in the same way that we do. So obviously we use physics in our jobs all the time, and we've had lots of training in physics, but we enjoy taking physics to people who don't even know that they love it yet, and also people that perhaps don't do physics in their jobs but like to learn more about it because they're just interested in it. So the Institute of Physics provides us with lots of opportunities to do courses and training and learn more things and keep up to date with our own science. But also it lets us network and meet other physicists, which is really exciting because we can then share best practice and help each other out. And one of my favourite things is it means that we get to do lots of volunteering, taking physics to people who don't yet know that they love it.
Although I said I'm a physicist, I studied physics and maths, and I now use my physics and maths skills as an engineer. And I work for Rolls-Royce in their civil aerospace sector, so they make aeroplane engines, and my job using my physics and maths skills is to ensure that we keep those engines running safely. And outside of work as well, so not just physics, I'm a brown owl with a fantastic brownie group in Nottingham, and I love doing things outside. I love swimming outside and running outside and doing physics outside.
We're going to do some physics outside today. Before that, I'll tell you a bit about myself. So again, I'm a physicist. I started out studying physics with theoretical physics, but then I moved very quickly into medical physics. So I do a lot of medical imaging. I use my physics knowledge to take medical images of the body, to see inside the brain and try and understand how the brain works. And that's really exciting for me because I get to talk to people, show people pictures of their brain, and they always say, wow, I've got a brain. And but I'm also using my physics skills every day. I also really like being outside. I do a lot of singing, and I do a lot of volunteering with the Institute of Physics, and we're really excited to show you two of our experiments today.
So the experiments or the investigations that we're going to show you are actually part of a badge. So the Institute of Physics joined with Girl Guide in Nottinghamshire, and we created a badge called I Am a Physicist. And anybody can do that in their groups or at home, and it's all with stuff you find at home. There's an experience section, a create section where you get to make some physicsy things. There's a bit where we want you to go and visit or meet someone physicsy, and then we're going to do 2 investigate things for you to try at home.
Brilliant. So this is the first one that we've got today, and we're going to give you a few moments to go and get all the equipment that you need. I think you're going to have most of this around the house. So you need some matching glasses. You can just do this with 1 glass. We've got 3 because we've got 3 different kinds of milk, but if you only have 1 glass, that's absolutely fine. You need some different liquids to blow bubbles with. So we've got 3 different kinds of milk. We've chosen to have skimmed milk, whole milk and soya milk, but you can pick any liquids that you've got in the house that are safe to eat, preferably, because you're going to be blowing bubbles, and you need 1 straw for every glass or every type of liquid that you've got. So we're going to give you a few moments to go away and get all of that equipment. So hopefully you've all been and got all the equipment that you need for this investigation. So what's the first thing we're going to do, Deborah?
So this investigation, we're asking a question, and then we're going to try and do some things to answer our own question. So my question is, I really enjoy having bubbly milk in my milkshake or in my hot chocolate, but I wondered what difference it would make using the different types of milk. So which sort of milk should I be using to get the best bubbles in my drinks?
And what even are the best bubbles? Do you want big bubbles? Or if you had lots and lots of small bubbles, are they better? Or do you want bubbles that last longer? Or do you want bubbles that make less effort to make, so you don't have to put as much breath in to get the same amount of bubble? There's lots of different ways of saying best bubbles, isn't there?
It's not a bubble meter.
Indeed.
So to do an investigation, because I just want to test what the difference is with the different types of milk, probably heard of a fair test. So we want to keep everything else the same, so nothing else is changing the bubbles, just the different types of milk. So can you think of any things that might affect it? I've already tried to do some.
Also, can you think of any things that you already know about these kinds of milk? So we know that these two kinds of milk are cow's milk. It's skimmed milk with the red lid and whole milk with the blue milk. What's the difference between those different kinds of cow's milk? The skimmed milk has got much less fat in it because it's had a lot of the fat removed, and the cow's milk has a lot more fat in because it hasn't been removed. And then we've got milk here made from a plant, made from a soybean, so that's going to have different kinds of fats in it. How's that going to affect the bubbles that we get?
So we've posed a question, we're going to try and make it a fair test, and we're going to try and have a guess at what we think is going to happen as well. So we're thinking about the different types of milk is what will happen, and we've tried to make it a fair test. If you see, I thought the shape of the glass might make a difference, so I've chosen 3 glasses the same, but what else might make a difference?
The material of the straw might make a difference.
So they're different colours, but they're all from the same pack.
And they're all paper. We don't have a metal straw or a pasta straw or anything like that. We're going to pour out the same amount of milk into each of the 3 glasses. We'll do that in a moment, but that's really important to make sure that we've got the same amount of milk. Also, how did you bring the milk here today? Were they all in your fridge this morning?
They were all in the fridge at the same time and all taken out at the same time.
That's important
So I
too.
think they're the same temperature. I've not heated them up for my hot chocolate. They're all fairly cool.
That sounds like a fair test to me.
Okay, I'm going to try and pour them out, and when I pour them out we can also see what differences to have our guess. Yeah, I'm trying to pour about the same in each one.
About the same.
A bit more. Does that look about right?
A little bit more whole milk, I think.
Actually, I can see
That
as I
looks
pour
good.
it. This one's formed some little bubbles already.
It's cheating. It's getting a head start. This one's got a few bubbles as well, but I think they're smaller bubbles. And this one hasn't got any bubbles at all.
These two looked creamier as we poured it out.
Yeah, that looks very creamy. So, now have a think about what you think is going to happen when you blow air through each of those straws. And we want you to really think about it and talk to whoever you're with about it. Tell them what you think is going to happen. So, have you had a think about what's going to happen when we blow air into each one of these glasses of milk? What did you think was going to happen? Okay, so now we're going to find out. Deborah, do you want to start us off?
So, this is the skimmed one.
Oh, look at that. Lots of big bubbles. And she's got to the top of the glass already. That was really fast. It was only a couple of seconds. So many bubbles, they're even blowing out the way. Go on, let's have a go at the whole milk. Oh, that's not going very well. It's making big bubbles, but they're not staying for very long. They just pop immediately.
That was a full breath like that one.
Oh my
Didn't
gosh.
get it anywhere near.
Didn't get anywhere near the top. Okay, so that's really interesting. So we've done the 2 different kinds of cow's milk, one with a much lower fat content and one with a much higher fat content. And we saw that those bubbles were quick to form, filled up the whole glass to the top, spilled over the top, and are still there. They've still lasted. The whole milk, the bubbles only came up a couple of centimetres, didn't last very long, popped very quickly. So do we think that's probably due to the fat content of the milk?
I think that's the main difference.
That's the main difference, isn't it? Right, what's going to happen with the soy milk then?
Have a guess based on knowing this stuff.
Do we think?
I felt when I poured it out, this one looked more like this one in the way it behaved.
It looks like it blocks the light out, doesn't it? It looks opaque, the soy milk.
It's creamier.
But my gut instinct tells me that soy is less fatty than whole milk. Because you make cheese and butter out of milk. Yes, you make cheese and butter out of milk. And I always think of soy as being healthier, I guess. So, I don't know, let's see.
Shall we try? So give it the same...
Yeah, give it the same treatment. Exactly the same amount of breath. Brilliant, so we've got huge bubbles there again. The bubbles look quite different, don't they? Do you want to quickly do the skimmed milk again?
Yeah, we can compare the two.
So those bubbles look quite similar to each other, don't they? And they're also not popping as easily. They probably pop in at about the same rate, aren't they? And do you think it took about the same amount of breath?
About the same amount of puff, yeah.
Interesting. So maybe we've discovered something like they have similar amounts of fat in them, or maybe there's lots of other factors going on as well. It's probably a lot more complicated than that. So hopefully you found that investigation interesting, and it's made you think about the different ingredients in food that you eat and
the different things you can investigate. So maybe if you were to judge, you wanted the ones that went the quickest, you could get someone to time you to get it to the top, or time how long it takes for them to pop.
Or you could even take a photograph of all of them and measure the size of the bubbles, or count how many bubbles you've got. Lots of experiments you can do. So we've got an investigation to do here, and we call this one Fizzy Rockets. And this one's really exciting. It needs vitamin C tablets, and these are called effervescent vitamin C tablets, and we'll be talking a lot about what those are in a moment. And then everything else, hopefully you will already have around your house, and you can go and raid the recycling bin and see if you can find some different kinds of containers. So we've got containers of different sizes, because it should work with any container of any size, but the really key thing is that you need to be able to get a really tight seal around the lid. So it's easier for us to show you this and make it look really cool if we do it with a film canister, but these are probably quite difficult to get hold of. So we thought that you could try it with some different kind of tablet pots, little yogurt bottles. These are tiny single portion yogurt bottles, or little water bottles as well. So anything that you can get a really tight cap. With the sports cap, that's really important. So anything that you can get a really tight seal on the top with. So and then you'll also need some water, and I'll give you a bit of a spoiler alert. One of the things we're going to ask you to do is stand it on its lid. So if it doesn't stand on its lid very well, like this bottle, get a jug or something just to sit it in. So we're going to give you a little bit of time to get all of those things together. So hopefully you've got all the equipment ready that you need for your Fizzy Rockets. And the really key important equipment is this. It's an effervescent tablet, and that means it fizzes. So we'll show you what that means. We've just got a glass of normal tap water here, nothing special about that, and I'm going to drop in an effervescent tablet. Can you see what that's doing? That's fizzing quite a lot. And what that's doing is it's producing gas, and that's making it look fizzy.
All those bubbles are rising to the top.
All those bubbles rise to the top. So it's really key that you remember that that's what we're dealing with. said, we've got an airtight container, a little film canister, and what we're going to do is we'll put some vitamin C tablet in it, and we'll add some water, and then we'll seal the lid up so that it's airtight, so nothing can escape the little canister. And then what do you think is going to happen with that effervescent tablet? So I want you to have a think about that, talk about that with the people who are in the room with you, when you put in an effervescent fizzy tablet into the film canister with some water, and it does that.
But there'll be a lid on it.
But there'll be a lid on it, so nothing can escape. What do you think is going to happen?
So this is going to be our rocket, and it does go really high and it does launch off with quite a lot of force. So this is quite a good investigation to do outside where you've got space for it to launch really high. And then the important thing with any sort of rockets or things that you're launching, you're going to put your fizzy vitamin C and you're going to put the water in. You need to do this quite quickly, but then once you've got it in there, you don't put any of you, especially your face, over the top of your rocket. You stand well back and tell everybody else around to make sure that they know there's a rocket there too. And then that should keep you safe. Sometimes it takes a little while before it goes off, but just stand well back, make sure everyone else is standing back, and leave it to do its thing. Don't go back to it.
So now we actually have to answer our question, what's going to happen with our fizzy rocket? So I'm going to put a bit of water in there. That's about half full. Is that about right, Deborah?
That looks good.
Brilliant. The lid on so it doesn't spill. And then I'm going to take one of my fizzy tablets. Now I put a whole one in that glass of water and it was very, very fizzy. So I think
Big glass.
we'll start with just half of one, I think. It's really not breaking in halves. And I'm going to crumble it up a little bit in my hands. And then I'm going to tip it in and I'm going to put the lid on, and then we'll see what happens.
So putting it in and putting the lid on has to happen quite quickly.
Very, very quickly. In fact, yeah, I won't show the camera, I will just do it. Upside down.
We stand back.
I'll stand back a bit.
And what's happening?
So what's happening in there? Do you remember what was happening in the glass? It was fizzing, fizzing. Oh, there we go.
So it fizzed and fizzed away till it didn't fit anymore.
Was that what you thought was going to happen? I guess we did warn you by saying it was called a rocket. Shall we try that one again? Now, do you remember what we were saying before about the scientific experiment? We can vary something to see what impact it has on what we see, our observed science, but we need to keep everything else the same. So what I'm going to do this time is I'm going to grind it, no. What I'm going to do this time is I'm going to put twice as much in. What do we think is going to happen then?
Oh, does twice as much mean twice as many bubbles?
So if it's twice as many bubbles, what does that mean for our rocket? Let's see what happens. So I'm just going to do exactly the same thing as I did last time.
It's still only got the same amount of space to fizz off into. Stand back. It's
Woo! I think that was faster. Okay, we're going for the whole tablet this time. Are we ready?
tablet in, lid on.
So that was a really fun experiment, wasn't it? Did you enjoy doing that? Let's talk about the science now. So we did that with one film canister and we varied the amount of tablet that we put in it, but we made sure that our method was exactly the same every time. I put them in at the same speed, I had the same amount of water in there, I put the lid on as fast as I could, put it upside down, and then we ran away. So what could you vary to try and understand how you can change parts of this experiment? I guess the first question is, what are you expecting to change? The one
I
thing
want my rocket to go higher.
You want your rocket to go higher? That's interesting. I want my rocket to go off faster. So that's something we could change. And so how are we going to be able to change that? What aspects of our experiment can we vary?
So we've changed the amount of tablet, but
Yeah.
we're also putting in water.
Yeah,
So we can change the amount of water.
you can put a bit more or a bit less water in. I ground the tablet up between my fingers to about the same amount each time. So you could try just dropping the tablet in whole, or just quickly breaking it into quarters, or grinding up really, really fine, like making sure it's a total powder before it goes in. Those would all be things to vary. And why does that matter? What are you changing when you break up the tablet into smaller pieces? You're not making more.
It's not more tablet, but more tablet
Surface.
is touching more water.
Yes, more of the tablet is touching more of the water, so you're increasing the surface area of the tablet that's in contact with the water. What else can we vary? We've got lots of cups here, we only used one of them, lots of different bottles of different sizes. So using this bottle, it took a certain amount of time. We could have timed it, you can time it yourself. What if we used this bottle? Would it take more time, do you think, to fill up? That's something that you can investigate yourself. This one, probably about the same, as long as the lid is really, really airtight and it's not escaping. This one's a lot bigger, so this one's going to take a lot longer, I would guess.
I tried that one and I couldn't do it, so that's a good challenge.
There's
to
a
try and
challenge
get
for
it
you.
to work with a bottle.
Try it with a bottle. So what have we learned?
Fizzy vitamin C and water fuels rockets,
Absolutely.
and they can
Fizzy
go really
Rockets.
high.
And they can go really high, and they can get your hands really sticky. So now you've done 2 investigate activities from the Girl Guiding Badge. And what does that mean, Deborah?
That means that you've done a quarter of the badge. I
Wow,
think.
a quarter of a badge. Don't you think it's worth going and finishing the rest of it off?
It's a lot of fun.
Yeah.
I've done it with my brownies.
Brilliant. So what we're going to do is we're going to give you the QR code. If you get your mum or dad to scan that in on their phone, and that will take you to the website, or we'll put the link in the description of the YouTube video. There's lots of different ways. Even just typing I am a physicist badge into Google will get you there, and there's a page all about the badge, all about the group of people that put the badge together. Lots and lots and lots more activities, places to visit, how to meet a physicist, all sorts of things. We'd love you to do every single activity, but actually you only need to do...
So I think there's an experience section, and depending on if you're a rainbow brownie guide or a ranger, I think you have to do 5 of those, and maybe a few less if you're a rainbow. And then you have to do a create activity where you get to build something like a Mars lander, and then you get to do, you need to go and meet a physicist or visit somewhere physicsy, and you've already done the investigation.
That's so exciting, that's really worth doing. So we're so glad to welcome you into the Club of Physicists, and you're going to get one of these I am a physicist badges, and it's just going to be great. So thank you so much for tuning in and watching our investigate activities today. I hope you've had fun, and hopefully we'll see you in the future.